With the
Yes,
today's
sir.
session. Okay, in the last class we have learned how to draw the isometric projection of various solids like the cone. Above the cone a hemisphere has been placed, so the how to draw this particular combination solid that we have discussed. Then we have discussed about the second problem. Sorry, it is on tetrahedron problem. As we have seen here, in case of the tetrahedron problem, so we have to draw the orthographic projection. Here orthographic projection is required. We have drawn the orthographic projection to find the what is the height of the tetrahedron, right? For finding the height of the tetrahedron, we have drawn the orthographic projection. Even for finding the midpoint or the apex point of the top tetrahedron in the top view, we have drawn the orthographic projection. So then with that we have drawn the isometric projection of the combination solid wherein a tetrahedron is placed above a rectangular prism. So this particular problem we have solved. Then also we have solved the third problem, which is a frustum of a square pyramid. It is almost easier as compared to the previous two problems. So a frustum of a square pyramid is placed above the square block. Drawing a square block is very easy. Above that we have to place a square pyramid. Bottom base is a square, top base is also a square here for this frustum of the square pyramid. So drawing this is also very easy, right? Now we'll go for the fourth problem, that is a square pyramid of base side 40 mm and height 50 mm rests symmetrically on a cube of edges 50 mm. It is similar to the previous problem, only the difference is here it is a rectangular block, that is a square block, right? But here it is a cube. A cube is there at the bottom. Above the cube you have to place a square pyramid of base side with only pyramid here, not the frustum of the square pyramid. So you have to place a pyramid above a cube. So we'll go for drawing the solution now. Initially we have to draw the base solid. For drawing the base solid, that is a cube, we'll take the line tool, right? I'll take the thin line only. Start with the thin line. So a cube of edges 50 mm here. So 50 mm angle 30 degree. Then 50 mm angle 150 degree. Then 50 mm angle minus 150 degree. Then 50 mm angle minus 30 degree. So bottom base of the cube has been over now. Bottom base of the cube has been over. Now what I will do is I will consider it as a top face instead of consider it as a bottom base. I will consider it as a top face. Now I'll give the thickness to this particular solid. I'll give the thickness. So what I will do is I'll take the line tool here. Thin line only initially I will take. So I'll give the thickness here. Thickness is nothing but here it is a cube. So thickness is also 50 mm 90 degree. I will go, sorry, 50 mm minus 90 degree I have to give, right? Select here, click this particular end point, then click type 50 mm minus 90 degree. Then I have to go along this line. So 50 mm, then minus 30 degree, right? Then I'll go this side 50 mm, then that is 30 degree. Then I will draw the lateral edges now. Lateral edges have been drawn now. So your cube is completed now, right? Isometric view of the cube is completed now. It is not a isometric projection, it is a isometric view because we have drawn it in true length. That is, we have discussed in the first class what is the difference between isometric view and isometric projection. So it is a isometric view. So if you convert into ISO while using the ISO scale, then it becomes an isometric projection. So we have to draw the isometric projection. So we'll do this at the end, that is after completing the square pyramid which is placed above the cube, then we'll convert to ISO. Now we have to go for drawing the square pyramid. So square pyramid must be placed above this cube here. So instead what I will do is I will draw it separately here, the square pyramid. The base of the square pyramid is a square. So the square will be seen as a parallelogram in isometric view. That parallelogram will draw it in true length here, 40 mm, then 30 degree, then 40 mm, 150 degree, then 40 mm, minus 150 degree, and 40 mm minus 30 degree, right? Bottom base of the square pyramid has been completed. Now I have to find the bottom that is the bottommost axis point. The bottommost axis point I have to find. For that, what I have done is I drawn the longer diagonal here. Where is that midpoint? That is the bottommost point of the axis of the pyramid. From that, I have to raise the axis height now. So I will take this midpoint and raise the axis height. So I'll take the axial line only. Axial line 0.25 mm thickness. So axis height is here 50 mm. So I'll choose the axis height as 50 mm, angle 90 degree. So this is the apex now. Apex has been drawn, right? Marked here. The apex is need to be joined with the base corners now, right? For that, I will take the line tool, continuous line only, right? I will use the thin lines only initially. So apex will be joined to the base corners like this, right? The apex of the pyramid, I will join it to the base corner like this, right? So three lines I drawn, another line is hidden, so that is not visible. So this is how the isometric projection of the square pyramid has been drawn. So now this square pyramid must be placed above the top face of the cube, right? It should be placed above the top face of the cube. For that, I will identify the midpoint of the top face of the cube. For that, I will take the line tool here. I will draw a midpoint line here like this, midline, right? So this is the midpoint. At this midpoint, the bottommost point of the axis should coincide here, right? I have to move. For that, I will use the select tool here. Then I will select the whole square pyramid. I will use the move command. Create copy is off. I will see that create copy is off. The bottommost point of the axis I will choose. Then I will move it over the top face of the cube. That is midpoint of the top face of the cube. When I move here, the midpoint marker comes. When the midpoint marker comes, then just click here. Then you can see the square pyramid has been placed above the top face of the cube of side 50 mm. So this is how the isometric projection of the combination solid can be drawn, wherein a square pyramid has been placed above the cube. Now what we have to do is the visible edges we have to retain, or we have to make them thick, and all the construction lines or hidden lines we have to keep it as thin, right? All the visible edges we have to make it thick. For that, I will hold down the shift key or control key, hold down the shift key and press these lines which are visible here. So these are the lines which are visible, right? Visible lines I will select here and I'll make them bold, right? Thick lines I will make. Select all these lines which are visible. These lines are visible. I will make it thick. As I told earlier, while drawing, you have to use 0.5 mm as the line thickness for visible edges, but for visibility of the screen for you, I will choose for 1.4 mm so that it will be clear, right? Understood now? So this is how I have drawn here, but this line, whatever inside this pyramid, it is not visible. Either you can cut into two parts, right? That is what the split command is. Using the split command, you can cut into two parts, and the inside line you can make it thin, and the outer line you can make it dark, or else directly you can use the trim command and delete this line. That is not visible, right? That now that line is not visible. Delete that line, and if required, you can draw that inside line as a thin line from here to here, so that you will have that thin line retained as it is, right? So this is how we are drawing the isometric projection of a combination solid. This is one of the problems. Now, if the students are having any doubts, they can ask now. So this is one of the problems. Any doubts, students? Is it clear? How to draw the isometric projection? Any doubts?
Sir, height is 50 mm, sir.
Yeah, height is 50 mm.
Okay, thanks.
So, height of the pyramid is 50 mm, base is 40 mm here. But for the cube, the all edges are 50 mm here. Okay? Okay. Yeah, we'll go for the next problem now. The problem number 5, again, it is a hemisphere problem. Hemisphere is placed over a frustum of a cone of base diameter 80 mm, top diameter 50 mm, height 50 mm. So hemisphere has been placed over a frustum of a cone. So you know what is a cone. Cone is having a base as a circle and there is an apex, right? So that is a cone actually, right? But the frustum of the cone means the top surface of the cone will be cut at a particular height of the axis, right? That is frustum of the cone. So base diameter 80 mm, top diameter 50 mm, and height 50 mm here. That is the frustum of the cone. Above the frustum of the cone, now we have to place a hemisphere. So this is actually a circle problem here. All are circular surfaces only. Bottom base is circle, the top face is a circle, and hemisphere also. In the hemisphere, the top face is also a circle. So we have to make use of the 4-center arc method here, right? We should be very conversant with the 4-center arc method for representing the isometric projection of the circle. So we'll go for drawing the solution for this problem. Frustum of a cone will draw first, then above the frustum of a cone we'll place the hemisphere. For that, I will use the line tool here, right? So bottom base diameter is 80 mm here, cone of bottom base diameter 80 mm. I will choose here the line here. So 80 mm, then 30 degree, then 80 mm, 150 degree, then 80 mm minus 150 degree, then finally 80 mm minus 30 degree. So the bottom base of the frustum of the cone, that is 80 mm, is enclosed within a box now. So that box is represented as a parallelogram in isometric projection like this. Now we have to, within this, I have to draw the circle now. I have to represent the isometric view of the circle. Circle will be seen as an ellipse in isometric view. So that ellipse we are drawing using 4-center arc method. For that, what I have done is I have drawn the longer diagonal and the shorter diagonal point, I'll join it to the midpoint of the opposite side. Shorter diagonal point, I'll join it with the midpoint of the opposite side like this. So this is the 4-center arc method. We are using this particular option, right? So now we'll take the arc tool, arc by center point. Here I'll take this intersection point as the center and here to here as the radius. I'll draw one arc, and then this intersection point as the center, here to here as the radius. I will draw another arc, and the third arc is drawn by taking the one end of the shorter diagonal. One end of the shorter diagonal will be taken here, and we are taking the radius is equal to from here to here. That is the third arc, and the fourth arc is drawn by taking another end of the shorter diagonal, and radius is equal to the length line joining that to the midpoint of the opposite side. So that will be taken and third arc will be drawn, right? So this is how we are drawing the bottom base of the cone. Bottom base of the cone is having a base diameter of 80 mm and top diameter, and now I have to draw that 50 mm. So this base has been drawn, right? One method how we can draw the top face is using the scale command, and you can copy and use the scale command, that you can do. Another is directly with the same method here, you can draw another circle here using 50 mm as the diameter. I will show that one now. So I will take the line tool here. Another circle I will be drawing here with 50 mm as the diameter, 50 mm, 30 degree, 50 mm, 150 degree, 50 mm minus 150 degree, and 50 mm minus 30 degree. So within this, now I have to draw another circle here using that 4-center arc method. So I am drawing that circle in isometric projection using 4-center arc method here, right? So then we'll take the arc tool here using the arc tool with this as center, here to here as radius. I will draw one arc, then this as center, here to here as radius. I will draw another arc here. And the third arc is drawn by taking this as center, here to here as radius. The third arc should be drawn. And the fourth arc, this one, and here to here as radius, fourth arc. Like that, I drawn the top face of the frustum of the cone. Now what we have to do is, we have to draw the axis of the frustum of the cone. Axis height is given here 50 mm. So I will take the axial line here, 0.25 mm thickness from the midpoint of the bottom base. I will write the height is equal to 50 mm, right? Right, height is equal to 50 mm at an inclination of 90 degrees. So this is the midpoint of the top face of the frustum of the cone. So this midpoint should coincide with the midpoint of this circle, right? For that, what we'll do is, we'll move. Use the move command here, select it, use move, create copy, see that it is turned off. The midpoint of the top face should coincide with the end point of the top end of the axis here. Top end of the axis, it should coincide here, right? Then we'll move. Now we can see we have drawn the bottom base as a circle, top face as a circle. The lateral sides we have to draw now. Lateral edges will not be there for the cone, so it will be only a lateral sides. So what we'll do is, this point we have to draw as an tangent to the bottom base. Tangent from this point should join to the tangent. For that, we'll take a line tool here, right? Continuous line only will choose, line, thin line only. So from here, I have to draw a tangent here. From here, tangent to the base circle, I have to draw. You can see here, tangent marker is appearing. When the tangent marker appears, then just click. From here also, same thing. From this, you draw a tangent to the base circle. Tangent to the base circle you draw, then it will be the lateral sides. So this is how we are drawing the frustum of a cone of base diameter 80 mm, top diameter 50 mm, and height 50 mm in isometric projections. So this is the isometric view actually of the frustum of a cone. Above this frustum of a cone, now what we have to do is, we have to place the hemisphere of diameter 50 mm. So this circle already we have drawn here, right? That is 50 mm hemisphere top face. Already I drawn. I'll just use move, create copy on, right? I'll just move over here, right? That is 50 mm circle already I had drawn here. So for this, I have to give the curved surface here. I have to give the curved surface. For drawing that curved surface, what we have to do is, we have to first convert this, we have to mark this radius of this particular circle. So from the midpoint, we have to go down by the radius. Radius is how much? Radius is 50 mm, right? And minus 90 degree. You have to go down by that, right? So what is that? 50 mm minus 90 degrees. No, is it 50 mm? Yeah, 50 mm minus 90 degree. So this radius is not 50 mm. No, diameter is 50 mm. Sorry, I just missed it. So line from here, the radius I have to go down here. Radius is 25 mm. Radius is 20 mm minus 90 degree. That means it will join here only. So this is your actually the radius of the hemisphere. The bottom portion of the hemisphere is this one, right? The bottommost portion of the hemisphere is this one. I'll just mark it as the axial line here. So this is the axial line. Now after this, we'll convert this into iso now, right? This diagram also we will convert to iso. This also we have to convert it to iso. Then we will move, right? Now I'm converting this into iso using the scale factor as 0.816. 816 the scale factor. Use this any reference point here. It is converted to ISO. So this diagram also I will convert it to ISO. Select it, scale, then use 0.816 as the scale factor and convert into ISO. Right? Both are converted into ISO. Now this curved surface of the hemisphere, the bottom curved surface of the hemisphere has to be drawn. For that, I will take the arc tool, arc by center point. So take the line from here to here, that is this one. Draw the curved surface of the hemisphere, that is with full length, like this. Right? So this is the curved surface of the hemisphere bottom. Now we have to move the hemisphere above the frustum of the cone. For that, what we'll do is we'll select this, use the move command, create copy, will turn off this bottommost portion of the hemisphere, this particular end point of the radius. So this should coincide with the midpoint of the top surface of the frustum of the cone. Right? For that, I'll choose this point here, end point here. So this end point should coincide with the midpoint here, the midpoint or the end point of the top surface of the axis. Right? So the top surface end point should be identified here. To that, we have to move here. Right? We have moved. Right? What I will do now is I'll slightly zoom this area. Right? So that you can see clearly all the visible edges. Now you have to mark now. You have to draw the visible edges with a thick line. Right? Here in this, so this line is visible. So this will be visible. This will be visible. These lateral sides are visible. You can make all those lines as thick lines. In the top surface, the whole circle will be visible. Right? I'll select all those things. Right? I'll click on this and visible lines are marked. And anything left out? There. This line is left out. We'll mark this line as a thick line also. Right? So this one is drawn. This curved surface also here, it should be thick. So that curved surface also we have made thick now. Right? And whatever inside lines are there, those inside lines now we'll trim off. Now I'll zoom this area so that I will get a perfect handle for trimming. Use the trim command. So this line we can trim off, this line we can trim off, that will not be visible. Right? Now I will go to the top here, and in this, so this line will not be visible here, so you can trim off this line. Here also inside edge is this one, you can trim off that. Remaining, I think all are visible edges will just fit to the screen so that it will be visible. Right? So it is how we are drawing the frustum of a cone, and above that we are placing the hemisphere. Now any doubts students can ask. Students can ask any doubts if you are having. Vivek, is it clear?
Yes, sir. Clear, sir.
No problem, no?
No problem.
Sir,
Yeah.
so in fourth question, why we didn't do the figure in ISO?